Nitrogen monoxide gas can react with oxygen to produce nitrogen dioxide gas, as represented below. A rate study of the reaction below yields the data recorded in the table below. So we have a series of 3 experiments where we have an initial concentration of both reactants, and we measure the initial rates of the formation of the product. Determine the order of the reaction with respect to each of the following reactants. Give details of your reasoning, clearly explaining or showing how you arrived at your answers. Okay, so let's first find the reaction order with respect to NO. And the way I'm going to do that is by looking at 2 experiments where the concentration of O2 is held constant. So experiment 1 and experiment 3, so that I can see what is the effect of the rate just by, in this case, tripling the concentration of the NO. Okay, so we can say that we have, let's see, 0.0600 over 0.0200. That gives me my change in concentration. I was at 3 times change in concentration. I tripled the concentration. And let's see the effect on the rate. So the rate was 7.67 times 10 to the minus 1 over 8.52 times 10 to the minus 2. So what happened here? I tripled the concentration and the rate increased by a factor of 9. So what reaction order do I have to have? Or in other words, 3 to what power n? What's my reaction order if I triple the concentration and the reaction rate increases by a factor of 9? Well, in this case, n has to be 2. So second order with respect to NO. What about with respect to O2? So in this case, I'm going to choose the 2 experiments where the concentration of NO is fixed. That's experiment 1 and 2. So that I can just see what is the effect of changing the concentration of the O2. Okay, so let's see. First let's start with our final concentration of O2. So 0.0900, and then divide by our original concentration, 0.300. So again, I tripled the concentration of O2. Let's see what the effect was on the rate. So 2.56 times 10 to the minus 1 over 8.52 times 10 to the minus 2. So let's talk about what happened here. I tripled the concentration of O2, and the rate also tripled. So remember, we call that a first order reaction with respect to O2. So the reaction order with respect to NO, second order. With respect to O2, first order. Okay. Given that information, in part B, we're asked to write the expression for the rate law as determined from the experimental data. So the rate is equal to K, concentration of NO to the second power, because it's second order with respect to NO, times the concentration of O2 to the first power, because it's first order with respect to O2. And finally, determine the value of the rate constant for the reaction, clearly indicating units. So K is equal to, I'm going to use the rate law. So I have the rate over concentration of NO2, the second power, concentration of O2. Okay. And then one thing that's interesting here that we can't forget, so this rate is the rate of formation of the NO2. But because we have a coefficient here of 2, we have to remember that this is a 1/2. Okay, remember back to the beginning when we were writing those rate laws, it was 1 over the coefficient times the rate, okay? So 1/2. Then we can choose any experiment that we want to. Just for convenience, I picked the data from the first one. So 8.52 times 10 to the minus 2 over, and we'll do units at the end in a separate fraction so I don't run out of room. Then we have 0.02 squared times 0.03. Concentration of NO squared times concentration of O2. So I get a value of K equal to 3.55 times 10 to the third. And then we got to do units. So on the top, we have moles per liter second. And then on the bottom, we have mole squared per liter squared times mole per liter. Okay. So what are we left with? Well, let's cancel what we can. These liters cancel. One is on the top and one on the bottom of a fraction. These moles cancel. So we get a value of K equal to 3.55 times 10 to the third, and it's moles to the minus 2 liters squared seconds to the minus 1. Okay, so there's an AP rate law free response example.